Good day everyone, my name is Reventing Flores and this is my channel. Last video we tackle about some topics related to trigonometry and for today we will discuss about inverse of trigonometric functions. So what is the trigonometric ratios again? It is the sine, cosine, tangent, cotangent, secant and cosecant. So that would be the objectives of this video. The learners are now able to solve and determine the inverse value of the given trigonometric functions. So this is the properties of a inverse function. First is a function must be one-to-one in order to have an inverse, of course, since some are don't have inverse functions. So we have to do some restriction to find the one-to-one, so to make it one-to-one function. So the second one is the graph of an inverse function is the reflections of the original functions about the line y is equals to x is equal to x. The third is if x y as a point on the graph of the original function, then y is x. Y and x is a point on the graph of the inverse function. So as you observe the formation from x to y, so we have this y and to x. From the given properties number 2, it is the reflection. So as you observe, nag-swap ang positions and x and the y. The fourth is the domain and the range of a functions and its inverse are interchanges, what I have said. So it would be the illustration of what is an inverse function. So we have this first. If the given function is, as you observe here, this will be the given functions we have. So we have y is equal to cosine of x, and this will be the restriction. No, this would be the inverse of the given function y cosine x. As we denote cosine, or the inverse of cosine is just cosine or cos raised to -1, or just simply arcos, since it is similar to the inverse. So first, but before that, we cannot find the inverse if we don't have these two lines here. Observe this black here and here is black. That would be our restriction. So we have this one-to-one function, and as you observe here this violet line is our the reflection, or the denotes the inverse. So we have this graph for our inverse, this orange line, and for the original function we have this blue line here. So next, just to evaluate what is the inverse function, that will be in solving the first illustration, what would be the graph. But if we were going to ask for the inverse given this equation, and then it would be, look, we have the first equation, y is equal to 3 plus 2 cosine of x. Then we are asked to find the inverse of that function. Then first step is just interchange the given variables, which is the y and x. So we have this x is equal to 3 plus 2 cosine of y, and next is just apply additive inverse by adding -3 both sides to come up with x -3, and eliminate that 3 from the other side. So we have this 2 cosine y. Next is to eliminate the 2, just multiplicative inverse by multiplication by multiplying both sides 1/2 to eliminate the 2. So we have this x minus 3 over 2 all over 2 and cosine y. But hindi pa yan dyan natatapos. To find the exact y or the value of y, since we are asked to find the inverse, then multiplicative inverse to come up with the arc cos x minus 3 all over 2 is equal to y, or just cos raised to negative 1, or the inverse cosine x minus 3 all over 2. So that would be the inverse function of the given equation or expressions. So that would be the illustration of the given or the given example. So we have this given equation, and the graph is the blue line, as you observe here, the blue line, and the restriction is the black. As you observe, we have this restriction here and the black line, and y is equal to x denoted as our the inverse. To visualize what is inverse, so we have this x here, and as you observe, the new inverse function here, which is the orange line, and as you observe here, the orange line is just a reflection of the one-to-one form, or the restricted one-to-one function here. This blue line here is just somehow the orange line is the reflection of the restricted function. And that would be all. Thank you and God bless.